Well, hello physics students, and welcome to this video lecture that is going to introduce you to torque and rotational motion. So first things first, if we relate back to the concept builder that you all performed today, you saw a meter stick, which is right here, that was resting on this thing that we call a fulcrum. And on one side of that fulcrum, there was a mass attached to the meter stick. Now, I think common sense tells us that because of that mass attached to the meter stick is going to want to rotate clockwise. And that is essentially torque. Okay, that mass is causing a torque. Now, the thing that we have to be careful with when we talk about torque is that torque is not caused by a mass. Torque is actually caused by a force, and that force is being applied a certain distance from an axis of rotation. So based on that brief description, torque is a measure of the tendency of a force to cause an object to rotate. Another way that I like to think about torque is that it's a twisting force which causes an object to rotate. Okay, so there's our verbal definition for torque. Now, we have a mathematical definition, of course. So torque, we use this symbol tau, is going to be equal to a force perpendicular times L. Okay, and that L is lever arm. Okay, so now if we go back up to our diagram here, and we want to break down the torque that's being caused by this hanging mass, okay, we need to be careful. The mass is not causing the torque, okay? It's the force of gravity. It's the force of gravity of this mass causing that torque, okay? So notice that this force of gravity is acting perpendicular. Okay, it's acting perpendicular to the lever arm. Okay, so the lever arm is the distance that force is acting from the axis of rotation. In this case, the axis of rotation is this fulcrum. Okay, so here's my axis of rotation, here is my lever arm, and here is my force that's acting perpendicular to that lever arm. Okay, now our units for torque are pretty simple. Okay, if we think back to our unit on force, our units for force are newtons, and our units for lever arm are going to be meters. So our units for torque then are just going to be a Newton meter. Okay, so pretty simple with the units for torque. Now, the final thing that I want to discuss in this video lecture is just some convention that we have for torque. Now, if we come back up to this graphic here, and we take a look at this force of gravity acting on this mass, we said that force of gravity is causing a clockwise rotation of that meter stick. Now, because of that clockwise rotation, we say that there's a negative torque on that object. Okay, so whenever we have clockwise rotation, because of a force being applied, we have a negative torque. Now, let's say that we had an object over here. Okay, we had a hanging mass over here. Well, that hanging mass is actually going to be causing counterclockwise rotation. If we have counterclockwise rotation, we say that positive torque, that there is positive torque there, okay? So basic convention, counterclockwise rotation, we have a positive torque. Clockwise rotation, we have negative torque. So very brief intro to torque. The big keys, that torque is a measure of the tendency of a force to cause an object to rotate, either clockwise or counterclockwise. Based on this mathematical definition, okay, we always want to keep in mind what that lever arm is. So that lever arm is the distance from the axis of rotation to that force. Okay, and that force is always perpendicular. Okay, so the force perpendicular to the lever arm is the force we want to consider when we determine the torque on that object. So in the next coming days, we're going to be applying torque in a variety of ways. Specifically, we're going to start out looking at rotational equilibrium, where we could have torques on both sides of a axis of rotation or fulcrum, but we're going to see that those torques actually equal one another. So take care, physics students. Have a good night.